we see it in the real world, and it lasts a few minutes, 2 at the most, 3. But what's supposed to happen on your model is that the period of time that it takes for the moon to go from, like, basically through that period there is measured in days. It's not measured in minutes. What we should see is the period where the moon passes behind or in the shadow of the Earth. That should take days when it's in a lunar eclipse. And we don't see it taking days, we see it taking minutes. Now the Earth spins, so what we should see is we should see the lunar eclipse, and then the next day we should see the lunar eclipse again, because the moon is in the point where it's in the Earth's shadow. There shouldn't be any light to it. And then the next day we should see the moon in the Earth's shadow again, and then the next day we should see it again, because on day 1 it would be there, on day 2 it would be there, on day 3 it might be in the middle, on day 4 it might be there, and I could push it as far as I want, really. I could make it up as I go along. But my point is, whilst it's behind the Earth's shadow, the lunar eclipse we should see repetitions of daily. We should see it per day, and we see it for minutes every day. Which, when you observe the lunar eclipse, it happens for minutes. That's totally inconsistent with the orbit of the moon around the Earth's.
Hello and welcome back, everybody. I hope you enjoyed that little clip of Riley, because this is what we'll be talking about today. How long does an eclipse actually take? Before I start, I will just say one thing. The Helmick and Riley video, hangout I was making. Yeah, I know it's been a while, but I'm lazy and I know it'll take a long time of commenting, so yeah, whatever, I don't care. In any case, Riley's claim was that an eclipse in reality, a lunar eclipse in reality, only lasts 2 to 3 minutes max, and that the model claims that it should be days. In any case, on September the 27th, 28th of 2015, there was a lunar eclipse, and that was visible from Denmark, where I live. I took a picture of it, 624 to be exact. I did start a little bit early to get ready. But what I used was my D7100, which I don't have anymore. I have a D600, and I sold the old one because I wanted full frame instead. Double sensor size, should be twice as good. I don't know. It's just better for what I do, personally. I shot it with my Tamron 70 to 300mm variable aperture lens with some very nice vibration control. It's not the sharpest lens, but it's good enough for me. I might sell it, I might not, I don't know yet. As you can see also on the picture here, it's the one with the gold ring. There's a couple of versions of it. One is also macro, but that's not the one I have. And since we're using APS-C sensor on the D7100, as well as like it's the same as on the D500 and stuff like that, we have a 1.5x crop factor. So the focal length I'm using, you have to multiply that by 1.5, and you get the equivalent focal range, like when you see on the P900 it says 35mm equivalent. That's what the equivalent focal range is on a 35mm camera. So we'll actually be, like when we're at 300mm here, we'll actually be at 450mm in the 35mm equivalent. Anyway, let's check. Let's see when this eclipse actually starts to take place. The internal time on my camera, I'm not actually sure it's correct, but whatever. And here's actually where I've messed up, I can see. So, let's go back and I'll actually show this to you. So this means that I'm actually zooming in more. I didn't actually remember this. I'm getting old. Let's go back to these. Yeah, 6000 by 400, that is 24 megapixels like the D7100 has. But in this, I've actually at 4800 times 3200. That's actually because I apparently put on the extra crop factor on the D7100. And let's just check this just to be safe. Let's see what that actually is. D7100 extra crop. I actually don't even remember that because I don't have it anymore. It's 1.3 extra crop. So now I do remember that what I have used at the actually eclipse, that was 240mm times the 1.5 normal crop factor, 360, and then times an extra 1.3. So when we get to the totality photos, I will have an equivalent focal range of 468 millimeters, if you guys want to verify the angular size and all that stuff. So, let's see when this bitch starts. Looks like it's at around here, so that would be 3 AM. I don't even remember what the time used to say, but I spent the entire night up with my camera on automatic shooting, adjusting it from time to time. As you can see here, this is actually out of focus, so you look at it very small and really overexposed. As you can actually see from the glare here, and we have a flare here. So, I'm not sure actually what Riley meant, if it was totality that was days, or if it was just the entire eclipse that was days. But this was shot over about 3.5 hours, so I can tell you one thing, it's not days. But let's go down here, we have some more flaring here, because I moved it around, and sometimes with this particular lens, it does have amazing vibration reduction, but it does mess up sometimes. I don't know why. It's very jerky. If you have that lens, you'll know what I mean. You can also see it here, this is very overexposed. You get a lot of flare in here. And around here I actually start to notice, I actually didn't notice this until quite a few shots later. Moisture got onto my lens, and I actually had to wipe it off. But after this I did check it, so not to worry. And you can actually see here that I took off the extra crop factor. Did I zoom in? Actually I didn't. That's funny. And I put it on again. I did some weird stuff that night. I have no idea why. Let's find totality for a second. That is around here. Let's just say this one, because there's a little sliver of white here. It is basically the same, but it could be exposure as well. So, anyway, 4:30 AM. That's when it starts. We'll go down a few more lines and check. This is actually overexposed. You can see that it's been edited by this thing down here. But it's actually at 4:40. It's also edited. Let's just develop it and turn that off so you can see the actual exposure. And we'll go more down. This was one that I exported and actually uploaded to Facebook. I gave it a 5-star rating so I can sort it. And oh, Riley, this isn't looking good for you, man. 4:55 AM. Looks like it's a little bit more than a few minutes, don't you think? And let's see, that's a little bit of what? It's got to be this one. So at around 5:03 AM. That's like half an hour. Actually, it's more than half an hour, Riley. So it does look like. Sorry. Now this was a weird lunar eclipse. It was basically the shadow was more or less skimming down here, as you can see on most of them. It's not quite red. That's why it's actually this fast. Usually, from what I've heard, it's a couple of hours. But 240 millimeters, and again, it does equal 468 millimeters. And as you can see here as well, it was shot at 5:03 AM. And just to be sure, let's just press this button, edit capture time, because you can actually edit your capture time. But unfortunately for Riley, the original time I cannot change, and that was at 5:03 AM. And let's just check the other one, just to be sure. Here. I actually haven't edited any of the original capture times. So it looks like, Riley, you were wrong. Let's just check the entire thing. I had to actually stop here at 6:24. Because I had to get ready for school, and I had my kids that day as well, so they had to get ready for school. I'm sorry, but that's like 3.5 hours, not several days. So, that's how it is in reality. For this solar eclipse, the entire thing was over in just over 3 hours, like more like 4 hours actually, if we just turn the timer forward a little bit. And totality for this one was around 32 minutes. Let's check Stellarium and see what this is. And this is actually a very old version of Stellarium. There we go. So, like I said, this version is pretty old. And the reason that I know that is because it's very, like, actually installed it was when I got my first telescope, and it's never even been on the internet as far as I know. I don't even know what version it is by now. But let's check and see what the model says. So we'll go 9 and we'll go 28 because it was after midnight. And we'll go to around 3 AM. And zoom in on the moon. And you can see here it's starting to get red here. Stellarium is a little bit weird when it comes to this stuff. It's a little bit weird to see it. But we'll go forward in time. So it still starts at around 3, like it did on my shots. I'm actually zooming out because this is a little bit boring. Let's go forward 1 hour. Because I had totality at around 4:30. You can see this is roughly the same here. And we'll go forward a little bit more. It's still more than 2 or 3 minutes, Riley, in reality. But let's see what the model says. So, as you can see, it's getting white here, so it has ended. Look for 1 more hour because on mine I stopped at around 6:24, as I remember. And you can see there's still some shadow here. Like I said, my pictures might be because of exposure. I'm not used to getting shots of stars and the moon and all that stuff. I usually take pictures of people, but you can see here it is more or less over at 6:30. Let's go back a little bit because I want to check something. Oh, we had Sadil Melik here. Interesting. Actually, it's not. But let's just check the stars. I'm just going to do one picture because it'll take too long otherwise. So we have up to the right here, we have some 2 stars here, and we have a double star here, and we have like a triangle of stars. So we'll go to one of my. Hang on, what time was that? This is at 4:22, so that's during totality. So let's check. That's 5 AM, 4:57, 4:48, 45. Yeah, that's around it. Also, I'll check one more so we can check and see if they follow it. We can actually see the double stars right here, but let's up the exposure. And this is going to be pretty noisy because it's a crop sensor camera that's cropped another 1.3 times. It's not going to be that good when it comes to noise. That's why I'm getting full frame, because it's a bit of noise. But we can see when we go up to the right here with double stars, straight up we have these two. And these two here, and you can see that if we go a little bit to the left, we have this one as well. We have this right to the left, a little bit up actually to the left, and we have them here. Now this star, I'm actually not sure if we can see it. It might be the dot, but it might just be a pixel. I don't know. But that's actually one more thing I want to show you. Like this is at 3 seconds. This is one thing I know about stellar photography. More than 2 seconds, you will actually start to get star trails. So, on my pictures, that's more than 2 seconds exposure. If it's not almost a line, it's most likely something with my sensor. Could be dust, could be dead pixels, I don't know. I don't really care, because we have actually seen what we want to see. So let's just go to a random spot. Let's go here. 3:34. That's pretty good because it's like an hour earlier. This way, 34. Let's find the moon again, and let's check if it's the same stars. Why can't I see the stars? I hate this program. I can't see the stars for some reason. That's not good. I hate Stellarium. I never use it. There we go. This is a little bit better. 419. You can see it's actually the same stars, apparently. The double star, triangle, whatever you want to call it. So 419 will be a little bit more ahead in time. Let's see, 410. Develop, and let's get the exposure up. And I don't actually have, oh, sorry, that was temperature. Double, actually this is jerky, as you can see, if it mirrored here. Need to go forward anyway, so let's just check and see. This is 415, and the other one was what? Thermos 419? Yeah, 420, roughly. Ooh, that was a little bit too long. 27, 25, 23, yeah, close enough. 23. It's still gonna be the same stars if we track the moon. They'll still follow. And that's actually what we see as well in reality. Here, and here again. So, let's just sum it up for a little bit. Riley claims that the model says it should be days. It's not days, it's still a few hours. And he says that, well, he says the model should be days, and in reality it should be minutes, yeah. So, model says a few hours for the entire thing, and for this eclipse as well, totality roughly half an hour. Reality says also a couple of hours for the entire thing, and for this eclipse, around half an hour of totality. So, I'm sorry, Riley. I think you need to research your claims a little bit better next time. Anyway, thank you for watching, and goodbye.